In this class, we're going to be looking at the introduction to your alkanes. Now listen, what will make me to know that you are even serious for organic chemistry first is this particular class. Because there are a lot of questions that are centered under this, in fact, a lot, right? And this is our lesson number 16 under your organic chemistry classes. Well, let's go together. First and foremost, in the introduction to alkanes, what should I know? First, I'd like you to come with me as we take a sweet ride together. Take note that early organic chemists, they were the ones that called alkanes paraffins. So we now adopted the name from them. What were they calling alkanes? They call alkanes your paraffins. That's why I said that alkanes or paraffins, alkanes or olefins, alkynes or acetylene. So your alkynes, triple bonds are the acetylene, double bonds, alkanes are the olefins, single bonds are the paraffins. Another important thing I'd like you to know here very quickly about paraffin is this. Don't forget that paraffin, right, is a Latin word. So the Latin word paraffin translated in English, what does it mean? It means little affinity. So alkanes or paraffins, that paraffin there means what? Little affinity. For example, now somebody is telling you, they come and tell you that you are the sugar in my tea, you are the egg in my egg roll, I cannot breathe without you. Then you now be smiling and now be doing, oh. If the person tell you that the love I have for you is like paraffin, what does it mean? Little affinity. Here you see, yeah, let's go. And I'd like you not to forget this very quickly, that paraffin also means parum affinis. Are you seeing it now? So it's either you say paraffin or parum affinis. Parum affinis means what? Little affinity. Paraffin means what? Little what? Affinity. Hold on a bit. The complete series of classes, right, as far as your syllabus is concerned regarding your Jamb And Waec, everything has been covered in details for you in the LearnLift app. And guess what? The sweet part is that you have access to your CBT, right? You have access to your video lessons, you have access to your notes, you have access to your past questions. Everything from the beginning to the end is directly in the LearnLift app for you. So all you have to do is just mark down to Play Store or App Store and download the LearnLift app where you follow all your classes from the beginning to the end. A quick one before we move. Let's get back to class. Enjoy. If you get this very fast with me, we can now rock this together. Characteristics of alkanes. A lot of questions are here. What are the characteristics that we see in your alkanes? Hold all of them tight. Number one character of alkanes is that alkanes are saturated hydrocarbons. Are they saturated or they are unsaturated? They are saturated hydrocarbons. In other words, they have the maximum number of what? Hydrogen that they should have. So they are saturated what? Hydrocarbons, number one. Number two, alkanes are non-polar compounds. Are they polar or they are non-polar? Non-polar. And you know that water is a polar solvent, right? Water. Okay, if I have this as my water, H2O, because it is a polar solvent, it means it will dissolve into H plus and then your OH what? Minus, right? And what can dissolve inside water? A polar solute can dissolve in water because water is a polar solvent. Polar solute can only dissolve in polar solvents. A good example is your sodium chloride, Na plus Cl minus. Here you see, it can dissolve inside your what? Your polar solvent, that is water. But you see, if you take a polar solute and you want to dissolve it in a non-polar solvent, it's not going to dissolve. The only things that can dissolve now in your alkanes, for example, are non-polar solutes as well. Are you seeing it now? Don't forget that alkanes are non-polar. Are they polar or they are non-polar? Non-polar, just know that one first. Number three, very quickly, is that alkanes are saturated aliphatic. We know that they are saturated hydrocarbons, but what type of saturated hydrocarbons are they? They are saturated aliphatic hydrocarbons. Past question. Are they aromatic? Or they are not aromatic. They are not aromatic. They are non-aromatic. That means they are aliphatic. But in the aliphatic that they are they saturated aliphatic or they are unsaturated aliphatic? They are saturated aliphatic hydrocarbons. That's what they are. And don't forget very quickly that they are sp3 hybridized. Alkanes, single bond, sp3 hybridized. Double bond, alkanes, they are sp2. The ones with double bond are sp2 hybridized. The ones with triple bond are sp hybridized. Constant questions. But please come with me again. The quick question is this. Your alkanes Are they saturated aliphatic or they are unsaturated aliphatic? Alkanes and alkynes are unsaturated aliphatic, but alkanes, being single bond, they are saturated what? Aliphatic hydrocarbon. That's all. So when it comes to creating an account, right? This is the interface of the app that you can see. You can see create account and you can also see login. Now, what you do is this: as a new user, you don't have an account yet, so you don't need to go and log in. You go and create an account as a new user. Click on that create account button. Once you click on it, the next thing is put your phone number. Place in your phone number. You can see +234. Then put your phone number, whatever your phone number is. If you don't have phone, you can use your mommy's phone number and put it there, right? Or your daddy's phone number. Use it, and then you can proceed and create the account. So let's go. So once you create the account, you are putting your phone number. What happened? Put your name, your correct phone number, please. Put your name. If your name is John, what do you fill in there? John. And then your last name, Frank. Fill in John Frank. And what's your email address? Okay, if your email address is johnfrank3@gmail.com, you fill it there. And then your password, very important. You create your own password, 6 digits. You can use your phone number, the first 6 digits of your phone number, or the last 6 digits of your phone number. Or you can, okay, since your name is John Frank, you can say, okay, my password name is John, right? John 123. And then you go and repeat the same thing, confirm password. What will you type there? Your John what? 123. You can decide to view it to yes or, and then see whether you are doing the same thing, whether what you are doing is correct, right? All you have to do is just click the I button there and then you view it. And then come to select education. You are preparing for Jamb or Waec. In select education, there are 4 plans there. University, that's for people that are in university. Probably 100 level, 200 level, right? Yes, their classes are also there. Secondary, for those in secondary school, primary. But for Jamb and Waec, click Waec Jamb Pursue TME, right? As the select education. Select level. You are not preparing for Pursue TME, you are preparing for Jamb and Waec, right? Okay, click on the what? Jamb and what? Waec. And then create your account. 2 seconds. Plus, you don't enter. It will load and then it will open for you. And it will tell you, welcome, John, right? Your classes are now what? Ready. What do? Start learning. Number 5, very fast. Alkanes have a bond angle of 109.5 degrees. You have learned that in the previous class, right? They have a bond angle of 109.5 degrees. Number 6, very quickly. They are tetrahedral. In shape. Are they trigonal planar? Are they linear or they are tetrahedral in shape? They are tetrahedral in shape. And then number 7, very fast. They have a general molecular formula of what? CnH2n plus your what? Your 2. Simple. And then number 8, all the carbon atoms that you see in your alkanes, are they joined by sigma bond or pi bond? They are joined by your what? Your sigma bond. I told that is the symbol for what? Sigma. This is it, your sigma what? Bond. So in alkanes, what do you see there? Is this sigma bonds or pi bond? Sigma bond. Sigma bonds or pi bond? Sigma bond. And again, sigma bonds and pi bond, which one is stronger? Your sigma bonds are stronger than your what? Your pi bond. You have looked at it in the previous class. If you get this very quickly with me, bro, let's go together. Look at this question, Jamb 1983, question 7. Don't fail any of the questions. The question all the way says, the three-dimensional shape of methane is? Methane is an alkane. What is the shape? Is it hexagonal? Never. Or it is trigonal? Never. Or it is the one you call your linear, or it is the one that you call your tetrahedral. What is the answer? Tetrahedral. Option D is the answer. Period. Oh, the same question was repeated in another format and another style in 2005 question 22. The question said the shape of the hydrocarbon CH4. Is CH4 not methane? Whether methane or alkanes as a whole, what's their shape? Is it square planar? No. Or it is tetrahedral, correct? Or it is planar, or it is linear. What is the answer? It is tetrahedral. Option what? B is the answer. That's all. Shall you see? Answer this question for me. Jamb 1992 question 41. Man, no vex. The question says the carbon atoms in ethane are Option A say they are sp3 hybridized. Option B say they are sp. Option C say they are sp2. Option D say they are non-hybridized. That's not true. They are, this guy is even out of the way. Are they sp3, sp2, or sp hybridized? They are sp3 what? Hybridized. And that makes option what? A the correct answer. Okay, sp hybridization, where do we see it? We see these guys in your alkanes. That's your what? Your triple bond. These guys, you see them in your double bond. That is your what? Your alkanes. Are you seeing it now? If you get this very quickly with me, I'd like you not to forget this question that was asked 1994, question 49. The question all the way says, which of the following orbitals of carbon are mixed with hydrogen in methane? Option A says 1s and 2p. In hybridization, we learned this. You should remember it, because in carbon, the one that we hybridized, I told you, if I have my 1s2, 2s2, 2p2 in your carbon, right? What did we conclude? We said that there is nothing that we consign this guy with hybridization. Hybridization is between 2s and 2p orbitals, right? Where it is in the excited state. In your 2s orbital, instead of me having 2 electrons there, only 1 will now be there. But in the 2p orbitals, instead of me to have 2 there, right, the vacant orbital, that is the 2pz, will be occupied by an electron that have received excitation from the 2s orbital. I explained this in the previous class. Now, the question is this. In the hybridization that will take place between your carbon, right, in your methane, where is it going to occur? Is it between the 1s and the 2p orbital? No, this guy is out of the way. Option B say it is between the 1s and the 2s. No, the answer is 2s and 2p. Option C says 2s and 2p. Option D says your 2s and 3p. What is the answer? Option C is the correct answer. Between the 2s and the 2p. The hybridization that will occur in methane, these 2s, right, that is s, we carry 1 and come. Your P, we carry 3, and what come? That's going to give you your what? S1P3. That's your sp3 what? Hybridization. A quick question. What is the percentage of S character in sp3 hybridization? Correct. 25%. What's the percentage of your P character in sp3 hybridization? Correct. 75%. Sure, you see now. Lovely. Yeah, let's go. If you get that very quickly with me, I'd like you not to forget this. The state of matter of alkanes matter a lot. Oh. Now, a lot of people will say, okay, sir, alkanes, so all of them are gases. Alkanes, so no, they are liquid. Some we say alkanes are solid. Where is alkanes in particular? Now, this is it. In alkanes, from your carbon 1 to carbon 4, all of them, they are gases. Yes. Carbon 1, that is from methane, right, all the way to butane. That's why you're cooking gas. What's your cooking gas? Is it not butane? It's a gas, cooking gas, butane. From your methane to butane, all of them are gases. Now, from C5 to C17, your C5, what is it? Pentane to your C17. What is C17? Heptadecane, right? Yeah, sure. So if C17 is heptadecane, that means from C5, learn this thing, so jam questions, no, they pass this. From your C5 to C17, right? What are they? All of them are liquid. In fact, your petroleum, that's why they always, when we get to petrol, I'm going to explain these things to you. When we get to your petroleum, I'm going to teach you all of those things. You'll be hearing things like octane rating, heptane, these guys are liquid. So from C5 to C17, all of them are what? Your liquids. Why from C18 to infinity, all of them are what? Solids. Shall you see it now? So C1 to C4, gases. C5 to C17, liquid. C18 and above, what are they? They are solids. To answer this question, pay attention to it. Jamb 1984, question 43. They brought this lovely question. The question says, alkanes, option A, are all gases. It's not true. We just looked at it. Because it is only from carbon 1 all the way to carbon 4 that are gases. That is from your CH4 to your C4H10, right? CH4, methane, to your C4H10, butane, all of them are gases. From C5, down to C17, what are they? Solid. From your C5 to C17, what are they? Liquid. But from your C18 to infinity, what are all of them? Solids. Thank you. Now, that means A cannot even be the answer. Option B says they have a general molecular formula of C2H2N plus 2. Ha ha ha. Wrong. You that went to choose correct. Is it C2 or it is your CnH2n plus 2? It is CnH2n plus 2, not C2H2n plus 2. Does it make sense? Correct now. Option C says alkanes contain only carbon and hydrogen. Alkanes, what are they? Alkanes are hydrocarbons. Alkanes, alkynes, the hydrocarbon, benzene, hydrocarbon, cycloalkanes, they are what? Hydrocarbons. So this guy, they contain carbon and hydrogen only. Yes, that's very true. Hydrides of carbon are hydrocarbons. And then option D says they are usually soluble in water. It is not true. Alkanes, are they soluble in water? No. Why? Because alkanes are what? Non-polar. Because they are non-polar, they cannot even dissolve in water themselves. So what is the answer? Option what? C is the correct answer. Shade is here. Beautiful. If you get this very quickly with me, I'd like you not to forget this very quickly. What are the reasons for the stability of alkanes? Sir Peter, there is nothing that is difficult about Jamb if you follow the classes back to back. What are the reasons for the stability of alkanes? You must not forget this. Number one, alkanes have no functional group. Somebody will now say, sir, now why? Alkanes have single bond. Alkanes have double bond. Alkanes have triple bond. The triple bond in alkanes is their functional group. Correct. The double bond in your alkanes is their functional group. Correct. The single bond in alkane is their functional group. Wrong. Alkanes have no functional group. Because, you see, the single bond that you see, in fact, if you are drawing your, there's no organic compounds that you are drawing that probably you will not come and be adding single bond to hydrogen and all of those things. You don't consider single bond as functional group. Functional group must be something that is unique, that is peculiar to you alone. That's what functional group is. Does it make sense? Does it make sense? Beautiful. The reason, okay, like your surname now, right? I know there are some people that bear your surname. Okay, your fingerprints. Are there other people in this world that have exact fingerprints like you do? No, it is unique to you alone, right? That's how functional group is. It's more like the family names of those compounds. Are you getting it now? The same way Toyota is family name. Hey, don't worry, that's discussion for another day. Let's go. They have no what? Functional group, number one. Number two, reason for the stability of alkanes is that no double bond. Do you see double bond in alkanes? No. Do they have triple bonds? No. Because they don't have double bond or triple bond, are they saturated or they are unsaturated? They are saturated compounds. Saturated compounds, are they reactive or they are unreactive? They are unreactive or they do not react. So alkanes, are they reactive or they are unreactive? Unreactive. That's the reason for their stability. I wish it is very, very reactive. It will not be stable. Now, number three, very quickly, they are unreactive at room temperature or very slow to react unless you now decide to catalyze it or you are applying heat to it. That's under the reactions of alkanes. We'll get to the class shortly. Number four reason for the stability of alkanes is that all the 4 valence electrons of each carbon atoms in the alkanes are used up. Take, for example, look at your methane, right? Your methane, for example, the carbon is tetravalent. All the 4 of them, everything there is what? Used up. Are you getting it now? That's the reason why they are what? Very stable. If you get that very quickly with me, please, I beg you to note 2 things with me. How many things? 2 things. Just 2. The first thing you should hold tight, all of these 2 things are exam question. The first thing you should hold tight is this. In straight chain alkanes, it is possible that an alkane is straight chain or branching. In your straight chain alkanes, now there's nothing like branching there. As the number of carbon atom increases, what happens? Please, especially in only straight chains, so the boiling point increases steadily. You see, the reason why people fail Jamb is because they are not prepared. Come on. In your straight chain alkanes, as the number of carbon atom is increasing, what is happening? the boiling point is also going to be increasing. A good example is what we see in your octane. Octane and your methane. Tell me, in octane we have C8. How many carbon? 8. In your methane, CH4, right? One carbon here. Octane, 8 carbon here. Forget the hydrogen, just focus on the carbon. Which one has more number of carbon? Octane. We say that as the number of carbon is increasing, boiling point also increase. So octane and your methane, which one we have higher boiling point? Octane has a higher boiling point compared to your methane. English is there, mathematics is there, biology is there, physics is there, chemistry is there. Your classes are organized, they are all there for you, right? What do? Okay, I want to start learning biology. So click on the biology, immediately you click on it, living organisms, that's chapter 1, right? Oh yes, that's strictly to your Jamb syllabus. And what happened? Let's say, for example, you want to watch your class on cell and probably cell structure, right? What happens is that you click on it. Immediately you click on it, you see all the classes will display. History of cell, types of cells, cell organelles, and all of that. Okay, sir, I want to watch history of cells. You click on the history of cell immediately. Hello, friends. Your class will start playing for you. It will start playing for you easy and direct. And what happened? You can even choose to make it full screen. Right? Make it full screen. What happens? You are started learning and you are enjoying your classes. In fact, you may choose to say, okay, I want to download my classes. In fact, you can fast forward, you can take it backwards, you can pause, you can rewind, anyone you want to do. You can even say, oh, sir, I want to download my classes, right? Probably you use Nightsub just to click on download buttons. When you click on download button, you see the download. Before you know what will happen, the download will start loading. As it starts loading, you can see it is moving. And then it's enter your phone. Are you getting it now? You can now go and start watching your downloaded classes. You can download as many classes as possible as you want to download. Now, you can even choose to say, okay, sir, that's the notes underneath it. It's the same thing for everything. I want to download my notes. All you have to do is click on the download for your notes. Before you know what is happening, it has entered your phone. You may choose to come to the notes, right? Under the characteristics of living things, let me open the notes and read the notes and go through the past questions. So you see, well organized and structured notes, direct to the points, focusing on your syllabus for you. There are past questions for you in abundance. You see, you have your past questions here. You can choose to say, okay, I want to zoom it in, right? And then the same thing for all subjects. And you are following. The answers are there. Number 1 answer is B. Why is the answer B? It is explained for you in details. Every singular thing. And then you are following your classes. You are done with that. You come to the next. You see your notes. Everything structured and organized to the core. In fact, at the end of the day, there is a blow kiss for you. You have done well. Get out. You too much. Everything is structured and organized for you in the app. Right? And you can now choose to say, okay, sir, what about chemistry classes or physics classes? You can do same. Use of English, all of them, they are there. When you click on your chemistry classes, what happens? Separation of mixtures and behavior. All of them are in line with your Jamb syllabus. Chemical combination, right? It just goes straight. You see, chapter 1 alone has 39 videos. 39, you sit yourself down, and you start learning. And you are following all of them one after the order. Does it make sense? Are you with me? When you want to access your download classes, all you have to do is just scroll down right on your home interface. Go to your access your download classes. Start now. You start. You see them, right? In fact, you may even choose to go and practice CBT, right, or past question. Let's say, for example, I go to my CBT, the one that has to do with my my biology. Then I want to take all the questions on that cell, probably your Waec cell or the Jamb question on it, right? Just to click on it. So you see, all the questions are there. There are 40 questions there for you already. All of them on that cell. What happened? Which of the following cell inclusion can destroy other cell organelles? Probably you now say, oh, some answer is lysosome. You choose it, you go to next like that. At the end of the day, you see your answer, see your corrections. All of these things are in the LearnLift app directly for you. Are you with me? So as far as your Jamb 2025 is concerned, my dear, you don't have an excuse whatsoever to have anything less than 300. Are you with me? All your classes are available for you. All you have to do, start learning now.
Download the LearnLift app now.
Sir Peter, answer this question for me. Jamb 2007 question 50. Look at the powerful Jamb question. The question says, which of the following alkanes has the highest boiling point? Not that the one you now be in the hall, you are looking at your computer is looking at you, you now turn at the counting ceiling. No, you are not prepared. If after you have watched all these classes, even yourself, you know that you are set for your exams. Which of the following alkanes has the highest boiling point? Is it your ethane? Now tell me, just tell me number of carbon in ethane. Ethane has 2 carbon. Is it your methane? Methane has 1 carbon. Is it your pentane? Pentane has 5 carbon. Or it is your what? Your propane. Propane has how many? Your 3 carbons. Which of the following alkanes has the highest boiling point? As number of carbon atoms increases, boiling point increases. Which one has the highest? It is the one with 5. Option C is the answer. Oh, you did see, huh? Answer this question for me very quickly. Jamb 2020 question 6. In 2020, they brought this question. Which of the following alkanes have the highest boiling and melting point? As the number of carbon atom increases, the boiling point do what? Increases. The same thing, melting point also increase. Option A says your CH4. Option B says your C4H10. C says C5H12. And then D says C6H14. Which one is the answer? Of course, correct. The answer is what? Option what? D is the correct answer. Why? Because D has the highest carbon. The C1, C4, C5, C6. Which one is the highest? C6 is the answer. And you're out of there. The first thing I told you that I beg you should note is very quickly. As the number of carbon atom is increasing in your straight chain alkanes, on the condition that it is only straight chain, the boiling point also what increases. The second thing you must hold tight now. Number 2, please note this very fast with me. Take note that boiling point decreases as the branching increases in your branched chain alkanes. This guy is for branch chains, not for straight chains. In your branch chain alkanes, as the boiling point is decreasing, branching is increasing, or as branching of the carbon begin to increase, as the branching is increasing, what will happen to boiling point? Boiling point will do what? Decrease. If you get that very fast, don't forget this. Isobutane is a cardinal example. Which one is isobutane? Isobutane, as don't worry, we'll get to naming of organic compounds shortly. I'll teach you all of these things so that you know them to the core. Isobutane is also called methylpropane. Don't confuse yourself. Isobutane is called your what? Your methylpropane. Propane, that's an isomer of butane. Sir Peter, come, let me show you. Your butane is your C4H10. That's your butane, right? And it's either you call it butane or N-butane. N-butane is telling us it is normal butane, straight chain butane. That means it will give me carbon to carbon to carbon to carbon. 4 carbon. All of them are straight chains. But in your iso, right? Isobutane, in fact, listen, your N-butane is C4H10. Isobutane is C4H10. I'll teach you all of these things as well in isomerism. Now, but look at it now. If you know you're going to add carbon here all together, only you drop butane in your notes now, it is C4H10. But your isobutane, this is how it is represented. Your carbon to carbon to carbon, 3. At the middle, come and put carbon there, 4. Then all of this side will now have hydrogen, 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 hydrogen. That's 3. Here is 4. Here is 5. Here is 6. Here is 7. Here is 8. Here is 9. Here is your what? Your 10. Isobutane. It's either I call it isobutane or your methylpropane. But listen, please. We said that boiling point decreases as branching increases. In your N-butane, normal butane, it is straight chain. In your branch chain now, what happened? It has branched. Because it has branched, boiling point there will decrease. Yes. So the more the degree of branching, the more there will be decrease in boiling point. My question is this: your isobutane and your N-butane, which one will have higher boiling point? Of course, the one that will have higher boiling point is your N-butane. Come. That's why we said that isobutane, right, has a lower boiling point because it has been branched. Compare the boiling point of your isobutane, the branch one is minus 11.7 degrees Celsius. While your N-butane, the boiling point there is minus 0.5 degrees Celsius. Which one is higher? Minus 0.5 is higher than minus 11.7. So as the branching is increasing, boiling point is decreasing. Don't forget that very quickly, because they brought it as an exam question in Jamb 1980 question 43. Please follow me. The question is a bit complex here. The question says, which of the following is the correct order in increasing boiling points of isometric? This guy now is now what? Pentane. Pents. Option A. Look at what they brought. Now, from this guy, look up very quickly. Follow me. Count. How many carbon is here? 1, 2, 3, 4, 5. N-pentane. Normal pentane. How many carbon is here? 1, 2, 3, 4, and then 5. It's either I call this middle guy here. This middle guy here, what do I call it? I will call that middle guy your 2-methyl butane. It's either I call it 2-methyl butane. 2-methyl. Don't worry, we'll get to name it. You will learn it well. 2-methyl butane, or I will call it your isopentane. Isopentane is also called your 2-methyl butane. This and this, they are isomers. This middle guy here, count. Here is your 1, 2, 3, and then this is methyl. This is methyl. I can call that middle guy, and the last guy there, that's your 2, 2, right? 2, 2, dimethyl, methyl, and 3 is what? Propane. All of them are isomers. They say, which of the following is the correct order in the increasing boiling point of the isometric pentane? Come, let me explain now. Hold your ear and follow me. First, I'd like you to note this and not forget. We said that as branching is increasing, boiling point is going to decrease. Which one is the most branched? The one that is the most branched is this guy. That's the highest branching. In fact, that's 2 branching. This guy has 1 branching. This guy has no branching. Right? Yes. So the one that has the highest branching, we have the lowest boiling point. So let me call this guy that has the highest branching there. Lowest boiling point. Let me call it 1, since it is the lowest boiling point. This one, we have the boiling point that will now follow next. Let me call it 2 because it is branch. This guy here that is not branch, we have the highest boiling point. Let me call it 3. Look at the way they brought the question. They said that 3, is it true that 3, for example, now, if here is 1 degree Celsius, that's the least now. Here is 2 degrees Celsius, moderate. Here is 3 degrees Celsius, high. Is it true that 1 is less than 2, less than 3? Or, okay, let me put it this way. Interpret this for me. Interpret this statement in mathematics. What does it mean? Is it true that 3 is less than 2? Reason it now. Is 3 less than 2? No. 2 is the one that is less than 3. In other words, I can say your 3, right, is greater than 2. Abi? Greater than 1. This guy is correct. Or rather, we better say 1. Correct is less than 2, less than 3. In other words, the one that we have the least boiling point should come first. Which one has the least boiling point? It is this guy here that has the least boiling point. So can we go together? Can option A be the answer? No, option A cannot be the answer, because the highest branch has the least boiling point. It should come first, because we are following less than symbol. Yeah, let's go. So can A be the answer? A cannot be the answer. What about B? Can B be the answer? This guy should come first. So B cannot be the answer. Shall you see now? Okay, what about option C? Can C be the answer? This guy should come first. Correct. This is 1. Where is 2? This guy is the one that is 2, right? And then this guy is the one that is what? 3. So this cannot be the answer, because it is 1, 2, 3. That's how you should arrange. Look at D. D says this guy should come first. Correct. Here is 1. Here is 2. Here is 3. That's the answer. The one that have the highest branching has the least boiling point, so it is less than the rest. Shall you see it now? So what is the answer? Option D is the correct answer. Very easy and direct. Does it make sense? So if you are sure you get this and you really do understand it, The next thing very quickly are the sources of alkanes. Where do we get alkanes from? I like to know there are questions here. Don't forget very fast that alkanes, you get them from natural gas, number one. In other words, where do you get alkanes from? Natural gas. Don't forget that the major source of your natural gas is methane. The major source of your natural gas, what is it called? It is methane. This is a constant question. What is the major source of natural gas? Methane. Number two, very fast. Methane is produced in marshy or swampy areas. You see, areas that are swampy, right? Where you have water, they are more like waterlogged areas. That's where you get your marsh gas from very well. That's why I discovered that that's why you observe that we always see crude oil majorly, those swampy areas. That's where they discover crude oil most of the times. So methane is produced in marshy or what? Swampy areas. And they are therefore called your marsh gas or your dam fire. What do you call your marsh gas or dam fire? Methane is called your marsh gas or your what? Dam fire. Because we see them in marshy environments. And then number three, very fast. Don't forget that you can also get your alkanes from your petroleum. So petroleum as well is another good source of your what? Your alkanes. Are you getting it now? And then number four, the last but not the least, is your coal mines. Your coal mines. What do you get in your coal mines? Alkanes. Oh, let's not talk much. Answer this question for me. Jamb 2003 question 45. The question all the way says the principal constituent of natural gas. Here you see. The chief constituent of natural gas, what is it? Is it your methane, or it is your ethane, or it is your propane, or it is your butane? What is the answer? Methane is the chief source of natural gas. Option what? A is the correct answer. Look at question 10 very quickly. Jamb 2006 question 15. The question says, the gas obtained as a product of the reaction on organic matter buried in the earth over a long period of time. What is the gas called? Option A say it is ethane, double bond. Option B says it is methane. Option C says it is carbon dioxide, and then option D says it is nitrogen dioxide. What is the answer? Please, the correct answer is your methane, option B. Methane, in fact, those are organic matter that have been buried right under the earth over a long period of time. What are they? Natural gas. What is the chief source of natural gas? Is it not methane? That's the answer, option B. And you are out of there. 10 questions down in this class alone. I beg you, right? This is everything about this class. First and foremost, I'll see you in the next class. In that next class, we're going to sit down. Preparations of alkanes. There are a lot of questions that are under there that you must also note very well. Please go to my notes. There are questions there. Waec questions are there. A lot of questions are there. Go and answer them. And then practice CBT. And always tell a friend about the LearnLift app. I remain your GSAP for the now, bro. Peace out. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.